Harness Continuous Efficiency is the first solution built for developers and DevOps teams, giving them a unique insight into cloud costs across their applications, clusters, and cloud providers. Instead of just providing an infrastructure view of cloud cost, continuous efficiency allows developers to see what they understand best, applications. So for example, in this view, we can see our application Harness over the last week was costing roughly $36 a day. We can see the true utilization cost of the application is 60%, so it's consuming 60% of the resources allocated to it, and 40% of those costs are idle. We can actually drill down into an application, and now we see the microservices view, which is what every developer wants to see, so they can drill down and pinpoint how much their microservices are costing every single day. We can change the time period, so we can go back to the last 30 days, and we can see a historical trend of cloud costs. So you can see there was an optimization around May the 15th where cloud costs dropped significantly. We can also look at cloud costs by environments. So if we want to compare cloud costs across development, QA, production, we can do that also by highlighting the different environments you see there. We can also jump straight into the application clusters. So these can be Kubernetes clusters, they can be Amazon ECS clusters. And this is what we call root cost analysis. Harness Continuous Efficiency is going to break the costs down by the actual utilized costs, meaning the costs that the application uses, the idle costs, which is the resources that are allocated and not used, and also unallocated costs, which is things like nodes that are not allocated to application cluster pools, but they're not being used. Okay, so you can see all the different clusters we've got here. I can drill into an individual cluster, and now we see the cost by namespace. I can also toggle, and I can go and see the individual nodes within that namespace. So I can see the CPU, the unallocated costs, the memory that's been allocated, as well as the machine types. I can also go back and look at workloads, and I can drill into a workload, and I can actually see the pods that are being utilized and understand the cost right down to the pod level. So you can see here, we've got workloads. Now I can go and group by pods, and I can see there was one pod allocated, the CPU requested, the memory requested, the cost, and the idle cost, giving developers full root cost analysis capabilities across their clusters. Developers can also drill down into the resources behind clusters, looking at all individual pods, the CPU, the workloads that are running, and we can trend CPU memory over time. We can also correlate cloud events with cost. So for this particular cluster, we can see there was 3 key events, and a simple click will reveal it was a Kubernetes resource change. So someone's updated the Kubernetes manifest, and we can see the actual diffs in before and after. This is extremely useful because if someone deploys a new manifest for a cluster, they might request more resources, in which case the cloud cost would rise, giving developers full context and visibility of all changes, including auto-scaling. In addition to showing cluster costs, we can also show the non-cluster costs by simply clicking on the cloud providers. This is the information that you get from your native cloud provider tools, showing you your cloud bill by service. So you can see in Amazon's case, you've got CloudWatch, you've got Elastic Compute, you can see Elastic Container Service, and all the other services you might consume as Amazon. Again, you can group them by service, you can look at account, you can even look at region. This is what you might be most familiar with if you've ever looked at your cloud bill. We also provide the same for GCP and Azure as well. So again, you can go and look at the costs you're used to from seeing in your cloud provider accounts. Continuous efficiency also allows teams to govern cloud spend through the concept of budgets. Budgets can be applied to teams, environments, applications, and clusters. So in this example, we have a production budget, we have an engineering budget, quality assurance, customer success, and sales. We can create budgets by simply giving it a name. We can then choose whether it applies to an application or a cluster. We can also then pick the environment we want it to apply to, and then we can specify an amount of the budget. Or we can choose the previous month's spend, so we don't want it to exceed what we had last month. We then simply pick the percent on which we want to alert on. So if we want to alert on actual cost or forecasted based on the burn rate to date, and then we simply pick the user group that we want to notify when these thresholds and budgets are exceeded. And that's another way developers and DevOps teams can get ahead of the cloud spend. The best part about Harness Continuous Efficiency is that it's fully integrated into the Harness Continuous Delivery as a Service platform. Meaning if you want to enable continuous efficiency, you simply go to Setup, you pick your existing Kubernetes clusters that are managed by Harness, you check cost efficiency, and it's simply a checkbox. A few minutes later, you'll start to begin information, and that's how simple it is to get started with continuous efficiency.